This is fantastic, and that was a tremendous demonstration of robotics. And I'm going to take us to a little bit more, somewhat sobering at some points, thought process about, does anybody here have children who don't have access to the internet? And all of us. It's important for us to have access. It's important for all of our machines that we're developing and building, and for all the technologies we're making to have access to the internet. And what we're doing, and really with the help of MASA and the vision, which is really, really incredible, is enabling affordable access for everyone. What if we could make sure that everyone in the world had access to the internet? That access to data was available everywhere, to everything. And so this is the vision, actually a mission of OneWeb, to bridge the digital divide globally by 2027. So this mission started a while back. I went to Africa, and I wanted to connect schools. There's a lot of schools without connectivity, about 2 million of them today. So I started running fiber, thinking fiber was the best thing out there. And I ran a lot of fiber. And I realized, running a lot of fiber, that it wasn't the answer. It was expensive. It was hard to run. It broke often, and you had to repair it. And you couldn't bring it to everybody. So there's lots of places around the world where fiber will end. So what do we do there? How do we get that high-speed internet access to everyone? Well, this problem plagues the world. 54% has no access. 4 billion people. We talked about 7 billion people being connected and 7 billion humans. Well, over half of them are without access. So we looked up. Rather than going down into the dirt, go up into the sky. Build a satellite system to bring internet access to the world. Now, many of you, or all of you, are in communications. And you know the most important thing of communications, the starting point, is almost always spectrum. And for us, the spectrum is managed by the ITU, the International Telecommunications Union. Now, fortunately, back in 1997, they had set aside a very large block of spectrum, a lot of forethought, and they put a lot of rules around it. But they set aside a very large block of spectrum for this purpose, for non-geostationary satellites to provide a bridge, a digital bridge, to bring internet access to the globe. And we acquired that spectrum. We designed and developed a technology that would follow all of their rules and gave OneWeb the priority rights to 3.5 gigahertz of globally harmonized spectrum. Now, in mobile networks, you think of 10 megahertz or 20 megahertz, or maybe 100 megahertz wide bandwidth. But this massive amount of bandwidth allows us to bring tremendous amounts of capacity to everyone. And I'll show you how that works. So we start with a satellite, or we start with the fiber on the ground, which is already out there. And in this case, the fiber is coming to a gateway in Egypt. It transmits this information up to the satellite. And when it hits the satellite, it comes down to the ground. And underneath a bunch of beams, lines of beams, each beam being a different frequency, the customer, the terminal on the ground, will change frequencies, receiving and transmitting its data in that frequency. But our satellites move, and the Earth moves, and they all have to coordinate together. So we have actually 49 satellites in a plane at 1,200 kilometers. And initially, we'll have 18 planes. The 18 planes and the nearly 900 satellites will give us complete 100% global coverage. And this is just the beginning. So we've talked about the mission and the spectrum. And then you have to have satellites, and the satellites need to be cost effective. Now, most of the time, satellites have been $50 million each for something like this. But we redesigned the satellites and developed a serial production mechanism for satellites that's never been done before, to bring these satellites down under $1 million. We were shooting for $500,000 per satellite. We're just a slight bit higher. So for the first time ever, we're actually doing serial production of satellites. And this isn't a hope of something we might do in the future. This isn't just a PowerPoint slide talking about a vision. This is a factory in Toulouse, France, where we're producing these satellites. And factories in Florida, where we're producing space structures, and in New Mexico, building solar panels, and another factory in Florida in Cape Canaveral, the world's largest purpose-built satellite factory, where we'll build 3 satellites per day. So to do this, we had to build a very highly automated factory to get that price down and to enable tremendous amounts of capacity for everyone in the world. So we also had to develop new technologies with our partners, and we have a lot of partners in this. As Mas had said, you can't do this alone. So while SoftBank is a large investor, we have many other investors and governments supporting us, cheering us on for this common mission of enabling access for the globe, which will benefit all of you economically, and it will make all of the other half of the world economically relevant, so that you can transact with them and bring your products to them, and they can develop their own technologies and maybe sell them to you. In this case, for space structures, we worked to design a panel. On that panel, which is part of the satellite, you see these little inserts. Those inserts, which are threaded screws, are very hard to put in, and they take 15 minutes per insert. There's 550 inserts per satellite, so it's 1 month's worth of work to build a satellite, just the structures. But with a partner, we developed the world's first and only insert machine, where we can insert these pieces, test them, and validate them within 1 minute, changing the time for building a system from 1 month to 3 hours. So we've developed a lot of technologies. We've got the satellites in production. What does it bring you? What does it bring people? Well, our capabilities, we're going to have well over 1 gigabit per second. Our first phase will be 595 megabits per second, with latencies below 50 milliseconds. So it's fully LTE compliant. This can sit in the middle of your networks, and you won't have to reprogram anything, any core networks or any software. It'll just work like all of your software does today. Terminals need to be easy to install. And most importantly, you need global availability. Because all fiber plants, all cable plants, they end somewhere. You've heard the term outside plant or outside the footprint. We want to make sure everybody, no matter where they are, can have access, equal access to the high-speed internet that we enjoy and our children enjoy. So who will buy this and how will they use it? Direct to consumer. A small terminal easily installed on the side of a house or on a school or a health center. We're targeting 1 billion subscribers by 2025. Cellular backhaul. There's 7.5 million cell towers today that are still 2G. They don't have the backhaul. No one thinks about the backhaul when they talk about 3G and LTE or 5G. But we're going to help to upgrade those cell towers from 2G into 5G world. And when we're going to deploy millions of 5G small cells, they'll all need backhaul. And OneWeb will be the unsung hero behind that 5G signal that you get. It will allow these these small cells to be deployed in places that you would never have thought, and self-deployed. Another big market, an interesting market, of course, is the connected car. As we move to autonomous vehicles, as you have your car take you to work, and your children are watching a movie in the back, and you may want to do video conferencing, or you may want to download and upload big files or work on a CAD program, you'll be able to have as much bandwidth in your car anywhere in the world that you go as you do in your office or in your home. So this is the system we're building to enable this global high-speed mobile internet. Of course, we'll have aircraft and trains and maritime uses. But this system, one of the things that we can't forget, and the mission that brings us all together, is the ability to really connect all of the schools of the world, to ensure everyone has equal access, and through great investors and through MASA's long-term vision and thought, which I thank you and our team thanks you, and the world really is going to benefit from, is your help in enabling OneWeb to make this happen. So thank you.
SpaceX plans to launch thousands of internet satellites. SpaceX has filed an application with the U.S. Federal Communications Commission to launch thousands of satellites in order to provide high-speed internet coverage worldwide. SpaceX's satellite system consists of 2 sub-constellations of space stations. The first, known as the LEO constellation, would be comprised of 4,425 satellites in an orbit of at least 1,150 kilometers above the Earth. Each satellite can provide service up to 43.95 degrees away from bore site. The second, VLEO constellation, would include 7,518 satellites, orbiting about 335.9 kilometers above the Earth. Each satellite can provide service of up to 51.09 degrees from bore site. The satellites in the LEO constellation can cover approximately 4.5 million square kilometers, while those in the VLEO constellation can cover less than 1/10 of that area. The system is designed to provide broadband and communication services for private and professional users worldwide. The deployment of the satellites is expected to begin in 2019 and be completed by 2024.
The goal of Project Loon is to bring internet to the almost 2 out of 3 people on the world who don't have internet access today. And we're doing that using high-altitude balloons.
3, 2, 1, 1.
The very first tests we did showed that it could work. So we began to think, wow, we're going to need to have a manufacturing system that can manufacture many, many of these balloons. We're going to need to have a mission control system that can keep track of the balloons. We're going to need to have an operations team that can launch these balloons and then recover them when they're ready to come down. So each piece of the process got to be bigger. We had to scale up. It was pretty challenging, getting the balloons to be more durable and more long-lasting. For a while, many of them leaked for some reason or another, and they would come down over the course of a few hours or a few days. It was like a detective job to figure out what was introducing tiny leaks. Now our balloons last over 100 days. At first, it would take us 3 or 4 days to tape together a balloon. Today, through our own manufacturing facility, the automated systems can get a balloon produced in just a few hours. We're getting close to the point where we can roll out thousands of balloons. In the beginning, it was all we could do to launch 1 balloon a day. Now with our automated crane system, we can launch dozens of balloons a day for every crane we have. To steer 1 balloon, left or right, you actually go up or down. And that's because in the stratosphere, the wind goes slightly different direction at a different altitude. To provide continuous internet service, you're talking a complex choreography where thousands of balloons are being steered and programmed all in an automated fashion. So another balloon is coming just at the right time to take its place of the one that left. Our mission control system allows us to track every balloon and lets us optimally position the balloons to provide coverage exactly where the people needing internet coverage are. We can track the location and projected trajectory of every balloon from the moment we launch it, on the way up till it reaches altitude, from the time we decide it's ready to bring it down, all the way down the descent till it's spot on the ground. With our system, we use LTE, which is a common protocol that most of the telcos around the world use. So anyone with a smartphone anywhere in the world will be able to get internet access. One of the key things we do is we partner with the local telco in every country. In New Zealand, we're partnering with Vodafone.
We like to think of ourselves as being very innovative in Vodafone New Zealand, so we thought this was a great partnership. Project Loon allows cell phone companies and internet providers to provide an internet to communities that don't have it. Ultimately, the goal of any internet service provider is to have 100% geographic coverage and all the capacity and speed that people expect. Project Loon will help deliver that.
If you look at the system today, it's amazing how much more advanced it is, from being 10 times higher data rate to the balloons lasting over 10 times as long, to the steerability of the balloons. We've flown in the tropics, we've flown in the Arctic regions. The technology is working. We're getting close to the point where we can bring the internet to people around the world.